I'm Vik Kumar. So I'm going to teach you about making healthcare predictive models in 15 minutes. First of all, thank you to Data Science Connect and Amelia and everyone else for all their hard work and organization. It's really humbling to be a part of this panel with so many distinguished and accomplished individuals. Before we dive into the code, I'm going to talk a little bit about my background. So I graduated with an MBA degree in 2009, and I was doing residency, and I realized, whoa, this isn't for me. I'd rather, sit in front of the computer and write notes than talk to people. I know it's kind of weird, but that's me. So it's had to enter into the world of computers and data science, and 6 years later, I found myself graduating from Georgia Tech with a master's in Computational Science and Engineering. Since then, I've worked at both healthcare and non-healthcare companies. 2 years ago, Packt Publishing contacted me and they asked me if I wanted to write a book on healthcare analytics. And I said, sure, that would be great. And it was published a few months ago. And like Amelia said, we'll be giving that away to 3 people. You can use it for bedtime reading, right before you want to go to sleep. It'll be good for that. So I want to dive into the presentation now. So it was going to be called 7 Steps for Building Healthcare Predictive Models, but I was editing it and I decided there should be 8 steps. So now it's 8 steps for building healthcare predictive models using open source technologies. Okay, so the first step is one of the hardest steps when you're just a freelance sort of data scientist who's trying to learn this and play around with it, is where do you get the data from? It's not like there's iris data sets floating around for healthcare. There are some that come with scikit-learn, like they have some in breast cancer and diabetes, but those are small data sets. They're not similar to the data sets you'll receive from a hospital if you ever want to do this in a for-profit setting or in a non-profit setting. It's different from the claims data that you would receive. But that being said, there are 3 sources of data I've found that are good for exploring healthcare data. One of them's more popular than the other. I got to that one last. So the first one is the NHA-MCS data. That stands for National Hospital Inventory Medical Care Survey. The links are here too, and that basically is similar to the data in an EHR, but it's survey data. So people, after they leave the hospital, the emergency room in this case, they write, what their demographics are, what their medications are, and things like that, and that gets put into this microfile of data. And the data includes a lot of different things, like reasons for visit, demographics, diagnostic codes, all these things. It's in a fixed width format, so it's a little harder than a C. Raise your hand if you've worked with fixed width format data before. Okay, so it's like a CSV file, except you need to provide the language with the width of each column. So it can be kind of a nuisance that way, but it's still good. And there's tens of thousands of records per year, and there's about 20 years of data. So this is a great way to get your hands on it if you're curious about healthcare data science. The next one is I came across a couple weeks ago is the Texas Public Use Data Files, and there's a link for it there. That's inpatient data, and it's discharge data, and that also includes similar data, not any vital signs or medications, but a lot of similar data to NHA-MCS. One of the good things about Texas Public Use is that it has tab delimited files. So you don't need to provide it, you don't need to go through the documentation and provide it with a column, but you can just read it in to using Python or Pandas or whatever you prefer. And there's hundreds of thousands of records per quarter. The last one, Mimic 3, you've probably heard about. I think it's done in conjunction with MIT, and it's ICU data, and it's a lot more clinical than the other 2 sources. It has clinical text, which is a really big deal right now in healthcare and in all of data science. And it has vital signs, lab tests, medication signals. It's from the ICU. There's tons of thousands of records. The downfall with Mimic 3 is that you do need to do some paperwork and get it approved by someone from MIT before they can give you access to the data, which is important because we don't want people, bad actors, accessing private healthcare data. So So once you have the data, you want to choose an open source technology. So Python is a popular one. The Python stack refers to the base Python. You probably know this already. There's also some extended libraries like Pandas, which is good for data wrangling, the data wrangling stuff in data science, which is like moving columns around. And scikit-learn, which is for making predictive machine learning models. And the matplotlib is your visualization. Raise your hand if you've worked with Python before. Okay, almost everyone. So the next one up is Apache Spark. Spark is different from Python in that it's multi-core. So it's it can be a lot faster than traditional Python. And they have a new data frame API that resembles PEMS. It's called Spark SQL. And all the functions in that are multi-core, so they use all the cores of your computer. And you can use either Python or Scala for the wrapper code, and then it has an ML library too that is built on the data frame API. R is another popular choice. It's open source. You can make statistical models. So once you choose SQL, they don't have machine learning for SQL yet, but someone's probably going to invent it like tomorrow or the next day. But SQL is good for data wrangling, data engineering. And then there's also business intelligence tools like Tableau is pretty popular for healthcare. But a lot of those require a license. So you have your data, you have your language that you're going to learn or that you already have learned. Now you want to decide what do I want to model? And healthcare is such a complex field because there's so many different diseases, there's so many different use cases. How do you decide what you want to predict and what will be useful to the population you're working with or the company the hospital that you've teamed up with? In open source world, unfortunately, we're kind of limited by the data. We don't have, a set of index readmissions and readmission people. The NHA-MCS data, you could do maybe emergency room disposition, which I talk about in my book. You could do mortality, predicting people that might be at high risk for mortality in an emergency room or an inpatient data. But if you are one of those fortunate people that either work for a company or want to start your own company, once you get a contract with a provider and you partner with them, you can get access to their data. You can ask them for the data you need to help them predict what they want to predict. So the government offers a lot of incentives to hospitals for certain measures. So it's become very common to predict, for example, who's at risk for being readmitted to the hospital after the discharge, because every hospital in the US gets penalized if they have a high number of readmissions. And that's split up into general readmissions. It can be heart attack readmissions, heart failure, pneumonia, all these different diseases. And then you also want another hot topic in predictive analytics right now is hospital-acquired conditions. Forgive the acronyms, but different type of hospital-acquired conditions. The hospitals want to make sure that they're not that the patients at their hospital aren't getting these. So if you can predict, for example, the first one, POTI, which is urinary tract infection, which patients are at high risk for acquiring that would be very valuable to a lot of the providers nowadays. 30-day mortality is another big one. And these aren't just for hospitals. There's also dialysis facilities that are audited by the government, and they need help with predicting which ones are at high risk for catheter infections or high calcium hypercalcemia. And then even SNFs and home health care, they want to know which patients are at high risk for being admitted to the hospital. So you can help almost any organization in the healthcare industry with these predictive models. Okay, so now we're going to jump over to Jupyter Notebook. So the fourth step of my 8 steps is import the data. So here we have Spark. Raise your hand if you've used Spark before. Okay, so OOS and Python. So this is a code to start a Spark session. It's not too bad. There's some additional code for starting on the command line, which we don't have here. But basically, it's a few lines, you can see. So it's just, Spark read load, you provide the file name, the the format, the separator, and the header. And you have the data, 780. I'm not going to do it live because it'll take a minute. But if you want to show the first 5 rows of the 2 columns, you just select the 2 columns you want, and then you show it. And then you can specify how many rows you want to show. And it's right there. So these are the record IDs and the discharge. And this is pretty format, that us computer nerds love. We use, dashes and pluses. Anyways, so here's an example in Pandas of importing healthcare data. So you have this first. This is a fixed width file. So you need some data about the data, metadata, and it just has the column name, the column width, what the variable type is. So you import that first, and this is how many characters wide each column is, and then you read that into different variables. Then you have your import statement. Again, it's very similar to Spark, and then you import it, and then you can print the first 5 rows of your data, and you can see here, it looks like the year is at the end, and that's right. So we're hoping everything in between is also right. So you should. Those are the things that I take leaps of faith on. But anyways, so yeah, you can see here's some of the data. So age, is here, length of visit, wait time, and we're going to use these later on to predict in our predictive model. Okay, so step 5, explore the data. And I'm sure if you're a data scientist, you've heard these steps before. What are some of the functions in Spark and Pandas that you can use to do that? So the print schema function in Spark, you can print all the different columns in your data and what type it is and whether or not it can be null. The summary function is good if you want to draw some box plots. This particular variable here is a categorical variable, so it's not really continuous, so you can't really draw a box plot with it, but we have an example of a box plot later. So in Pandas, you have the info function, which is similar to the Spark one, and then we have this one, describe, that tells you, this is helpful to start exploring the data, how many unique values are, what the mode is, and then you have this box plot function, which I just came across, which we can draw a box plot. So here we have age separated by patients who were discharged from the emergency room and those that were admitted to the hospital for the emergency room. And you can see that the people who are discharged tend to be younger. And that makes sense because older people generally might have more medical problems, might be sicker, might need a hospital stay. So those are just some functions to get started on exploring the data. And then pre-processing the data, this is a huge task. And so here are just some steps for you. If you want to finalize your target variable that you're predicting, in our case it was predicting emergency room disposition, whether or not they're admitted to the hospital. And we've done that here. These notebooks are available on GitHub, by the way. So
you're going to share the code with us?
Yes, it's already on GitHub, yeah.
Great.
And I'll share that at the end. So then splitting the data into train and test sets is important. The scikit-learn has a handy function for that. Feature engineering. So say you have a hunch that people who come to the emergency room in winter are more likely to get admitted than people who come in any other month. So you can make a winter feature, you can make an is-night feature to predict whether or not the nighttime visits are more likely to be admitted. You want to impute missing values. A lot of these data sources I mentioned have missing values. So you can write a function for that. And then clinical codes. That's a big deal in healthcare. A lot of these data you get from hospitals and stuff, it's not going to be like a continuous vital sign or data. It'll be a code, like saying, 85 this patient's positive for 85.38. And you're like, what does that code mean? So you might have to separate the codes into different diseases. It helps if you have a file that has codes in it, like this file here, it has a reason for visit codes. And then you can use functions like this to separate each code out into a separate column. And then we build a model. I'm going to jump over to this notebook. So in the book, I talk about logistic regression, random forest, and neural network. I'm not going to use a popular term for neural network. It starts with D and ends in learning. I think Todd used it earlier, but I'm gonna stay away from that because one of the data scientists I work with, he cringes every time I say that word, so I don't use it anymore. So here, making the model is actually one of the simple parts in data science. In scikit-learn, a lot of the models are interchangeable. So you just initialize an object for a model, and then you fit it, and then you can do predictions on it. You can score it. Each model has a similar API. You fit the model, then you score the model, and then you can print out information about the variables. So here we have, this is a model for predicting emergency room disposition, and the accuracy is about 88%. And here you can see some of the features that the model thought was important. This is kind of sloppy, but obviously if someone's going into labor, they're going to be admitted to the hospital. A lot of these things like psychiatric disorders here, shortness of breath, chest, these are serious things. And at the bottom, some of the less serious things like toothache and soreness and skin rash, these are things that people aren't going to say at the hospital. And then random forest, you can see the code is pretty similar. So they're all interchangeable in scikit-learn. And here are some more feature importances. So the vital signs, the age, all score really highly. Some of the codes that probably have no data associated with them are at the bottom. So and then we have a neural network. And so when you do the neural network, it goes through in scikit-learn, it goes through iterations, and it's kind of cool because you can get to watch it on your screen. It's more interesting than watching paint dry, that's for sure. You see all the iterations and the error rates, and then the accuracy you came up with in this model is 87%. So I think it's about the same. It's clearly overfitting here because the training accuracy is a lot higher. So does anyone have any questions or anything before? Those are the 8 steps. Just to close out, thank you very much for listening. Let's connect. The notebook is available on GitHub. That's my GitHub. My book is on Amazon. There's some discount codes for you. 40% ebook, 10% off the print book at packtclub.com. If you have any questions, there's my email address. Thank you very much.